Hi, this video is a continuation of stoichiometry, and we're going to look at the molar volume of a gas. All right, molar volume. It is the volume of 1 mole of any gas at standard temperature and pressure. And standard temperature and pressure will be abbreviated STP. So, what exactly is standard temperature? Well, that is 0 degrees Celsius. And standard pressure in the unit atmospheres is 1 atm. There are many different units for pressure, but I like to use atmospheres. Okay, so what this means is that any gas, no matter what it is, if it is at 0 degrees Celsius and 1 atm, known as STP, its volume will be 22.4 liters. And so this little picture here is just showing you this cube is 22.4 liters and comparing it to the size of a basketball, soccer ball, and a football, just to give you a visualization of the size of 22.4 liters. Again, gas molecules are very far apart from one another. They do take the volume of their container. They will expand to take the volume of their container. But if you are at standard temperature and pressure, 1 mole of the gas will have a volume of 22.4 liters. And so this is a gas, probably hydrogen or nitrogen, because it's diatomic. So you see the 2 molecules there. All right, well, let's go ahead and practice with this new conversion factor. So we have 3.25 moles of hydrogen gas at STP, and they would like to know what is the volume. And hydrogen is diatomic. And again, 1 mole has a volume of 22.4 liters. And notice with the dimensional analysis, the moles cancel, and we're going to multiply the 3.25 times the 22.4, and we wind up with 72.8 liters of hydrogen gas. All right, so if you have moles of hydrogen or moles of any gas, if you're at STP, multiply by 22.4, and you will have its volume. Now let's go backwards. Let's go ahead, we're going to start with volume and go to moles. So this time our gas is carbon dioxide gas, and you have 2 liters of it. So the vessel is 2 liters, and it's at STP, and it's carbon dioxide. Sounds like Gracie wants to come in. Okay, so you have 2 liters of carbon dioxide, and 1 mole has a volume of 22.4 liters. So the liters cancel and we're left with moles. So this time what we're doing is we're taking 2 liters and we are dividing by 22.4. And so we end up with 0.893 moles of our gas. So when we started with a volume, we divided by 22.4. So here we go. This is just another visualization. If you start with a volume of a gas and you're at STP, you're going to divide by 22.4 to get your moles. If you started with moles, just like the other things, if your unit is moles when you start, you're going to multiply. And this time our conversion factor is 22.4 liters in 1 mole. Okay, this is for honors only. This slide is for honors only. But standard students, the last slide is for everyone because I'd like to summarize. All right, calculating the molar mass of a gas at STP. Well, a molar mass we can get if we take a gas's density and multiply it by a molar volume. All right, and our molar volume is 22.4. All right, what is the molar mass of a gas that has a density of 3.16 grams per liter at STP? Okay, well, let's go ahead and do 3.16 grams per liter, and then let's multiply that by 22.4 liters per mole. Look at what happens to our units. The liters cancel. We're left with the unit grams per mole, and that is the unit for molar mass. And so we went ahead and did that, and our answer is 70.8 grams per mole. So this was probably chlorine gas with a molar mass of 70.8 grams per mole because chlorine is diatomic. So again, you can get a molar mass from a density of a gas if you know its density at STP. So this type of problem is for honors students only. But I would like to summarize, and I really like this diagram a lot. This is everything that we've been doing in stoichiometry in this whole unit. Okay, moles is in the center of everything. And if you start with moles and you wanted to go to particles, it could be ions, it could be molecules, atoms. What you do, if you have moles, you are going to multiply by Avogadro's number, 6.022 times 10 to the 23rd. However, if you start with these particles or atoms or molecules or ions and you want to go to moles, you divide by Avogadro's number. Okay, let's look at moles here. We're in the center. We would like to go to the volume of a gas at STP. That's what we just did. And to go in this direction, away from the moles, you start with moles, you multiply by 22.4. If you have the volume of a gas at STP and you want moles, you are going to divide by 22.4. If we are at moles and we want to go to a mass, molar mass is our conversion factor. Remember, it's formula weight, but now we're using the unit grams per 1 mole. And so if you have moles, you multiply by molar mass. If you have a mass, so you start with grams and you want moles, you will divide by molar mass. To be honest, everything that we've done in the last couple of videos is contained right here on this diagram. All right, well, we're going to practice this some in class, so we'll see you tomorrow.